The theme of my presentation is text recognition and recording in the video mode for the Android operating system. Recognition of text has been developing quite rapidly later, but there are many disadvantages in the field that can be implemented and improved. The Android operating system contains a character repository of many languages, but not the Ukrainian. So we propose a method and algorithm for recognizing text in Ukrainian and modifying it for video mode. This algorithm can be used for recognizing the text in its sounding and implementing it for people with visual impairments. Let's look how program will works at the user side. Consider the user case diagram. The user can interact with the screen and with the item of menu. He can change the language, English or Ukrainian. After recognizing the text, the user can count number of words on the screen, their correct spelling, as well as listen to the select text in the frame. The next diagram is the sequence diagram. It shows how the user interacts with the system. The user selects the recognition language and the system recognizes the text. After that, the user can tap on the screen and the text will be listened to. Also, when the user clicks to the menu item count number of words, the system will display results. Also, the menu item is to check the spelling of the word. As soon as the user clicks it, the system will display a message whether the words are written correctly or not. This slide shows a class diagram. The software product consists of 6 classes which are closely related to each other. Main of them are text recognition, frame driving, text sound, and text recognition algorithm for video mode. This diagram details all the attributes, methods, and a relationship between each classes. So how the program works at algorithm side. Since the image is not static but variable, its performance is important to us. Updating the frame of your phone is in the range of 30-60 frames per second. For maximum text recognition performance, the program will frame the found text. Updating the frame and text inside, it will approximately 15-30 frames to reduce the load on the phone. The user won't notice the big difference. If the characters are not described, the system simply misses them and they will be not visible on the screen. The system will automatically delete the old text frame in 15-30 frames and create a new frame with the new data immediately. Once the text is found, the user will be able to click on it and hear the text within the frame. To recognize text in English and Ukrainian, an XML file was created. This file identifies characters, uppercase and lowercase letters. Each character is assigned its own name. The next step is to connect the class to recognize the text in the image. The text recognition is as follows. A character is taken from the screen and compared character from an XML file. To compare characters from an image and from an XML file, the character in the image is converted to a specific standard, namely the font and its size changes. When the symbol from the image and the file are compared, this uses a script to compare character from OCR technology. Once a character is found, it stores in a temporary buffer that sequentially accumulated the characters. As the text is found, the user will be able to click on it and hear the text within the frame. Let's consider graphs, how the algorithm works depending on factors. This slide shows the graph of text recognition for changing light. 20 tests were performed in which the light varied from lower light to brighter. The graph clearly shows that the brightness increased, the speed of the text recognition increased too. So what is took less time to process the image? Here are some test cases. On upper left edge you can see the image with the lowest light and the lower right the brightest image. The next test is recognition when the number of symbols changes. 20 tests were performed. The recognition starts with 3 symbols and increase by 1 each time. Based on the result, we can say that as the number of symbols increased, the program will need more time to process it. As you can see, not only the number of symbols were tested, but also the interaction with different registers, uppercase and lowercase. It was also tested how the program works with the different types of fonts. The results here. And this slide explores how the program works with the different text sizes. As a result, shows the program copes well with this. Let's move on research to prove that software development was yield results. Tests were developed from that shows the performance of regular OCR and improved algorithm. Testing were conducted with a change in illumination, the change in number of frames, and altogether. This, this one shows the test when changing light. The second shows the text when changing the number of symbols. And the latest show the test when changing the illumination in the number of symbols. The accuracy of text recognition was also verified. Verbal text recognition accuracy exceeds 98%, but if one of the conditions is violated, the recognition accuracy can drop by 15–20%. Recognition accuracy dropped to 40% due to camera operating in the video mode. In conclusion, we can say that during development of recognition algorithm, we achieved the following results. Implementation of the algorithm of recognition of the text in the video mode for the visual impaired. Algorithm for recognition in Ukrainian and English in video mode. Implementation of the algorithm of sounding the text when you tap the screen. Implementation of selection of border the found text. An Android software product for visually impaired and people learning to correct pronunciation of foreign words. Studies have shown that the improved algorithm speeds up the recognition of text by 4–5%, which helps the better recognize the text, but the performance depends on external factors. Recognition accuracy depends on external factors which degraded recognition by approximately 40%. Thank you for your attention. It's all for me. Bye.